This is part 152. It's line 18A, a3z2b Stellarator, W7-AS Plasma Accelerator, Hydrogen Deuterium NBI Wow Seti. This is about brand new technology currently being built. It's another type of colliding system, and so this came up in the Wow Seti signal, so I'm assuming some of the formulas that I've come up with in line 17 and 18 hopefully can be tested at these new facilities, okay? So there's the alien radio signal there. And so I googled first Deuterium NBI discharge. I didn't know what it meant. And I have a PDF file for you to look at. Nuclear fusion volume 39. It's called the hydrogen isotope ratio in W7-AS during Deuterium NBI heating. And there's the authors there. And abstract. Okay, with a so-called sniffer probe, the fraction of hydrogen during discharges with deuterium NBI heating was studied in the plasma edge of the Stellarator W7-AS. As expected, the ratios were significantly lower than in discharges with hydrogen. Doesn't tell you what year this came out. Okay, sorry, I was just looking to see when it was done. So with so-called, NBI heating was studied in the plasma edge of the Stellarator W7-AS. As expected, the ratios were significantly lower than in discharges with hydrogen NBI heating, but were higher than those in discharges with only ECRH. An examination of the possible reasons for this increase concludes that it is not only partially caused by the direct influence of neutral injection, but also depends on the energy content of the plasma determined by the heating power and the confinement time. Of course, the isotope ratio also depends on the starting conditions, i.e. the isotope ratio before the onset of NBI. April 1999, and it was received in 1997. Okay. The next PDF that comes up is Nuclear Fusion Volume 39, Fast Equilibrium Interpretation on the W7-AS Stellarator using Function Parameterization. And there's the authors. Interpretive methods for the calculation of plasma equilibria consistent with experiment are common to tokamak analysis, but are generally unsuited to stellarators due to the computational resources required by current 3D MHD equilibrium codes. To overcome this, we apply function parameterization techniques to facilitate fast equilibrium recovery on W7-AS. These are used as the basis for a rapid interpretive method of equilibrium reconstruction, whereby the plasma pressure profile is inferred from the spatial to flux transformation implicit in electron pressure profile measurements made with the Thomson scattering diagnostic. This interpretive method produces results of comparable or superior quality to conventional methods, but is many orders of magnitude faster. The scheme is tested against standard stimulations of W7-AS discharges. Another bug bites the dust. I almost got that one in my mouth. April 1999 it was published. So February 21st, 2012, my thoughts, okay? Quote, we apply function parameterization techniques to facilitate fast equilibrium recovery on W7-AS. This interpretive method produces results of comparable or superior quality to conventional methods, but is mainly orders of magnitude faster. The scheme is tested against standard stimulations of W7-AS discharges. Quote from Fast Equilibrium Interpretation on the W7-AS Stellarator using function parameterization. So I googled Wendelstein 7X Stellarator, and this is what it looks like. Kind of looks like a bit like a slinky, with a ribbon in it. That's what I thought when I first saw it. Okay, invention for plasma currently being built in 2012. It's an IPP project, so Wendelstein 7X is what it's called. The Wendelstein 7X Stellarator, now being built at the Griswold branch of IPP, will test a magnetic field optimized to overcome the difficulties of previous Stellarator concepts. The quality of plasma equilibrium and confinement will be comparable to that of a tokamak. And that's from the www.ipp.mpg.de. And all the rest there. Okay? This is what it looks like while they're building it. It's quite detailed. It's got a lot of bars and stuff on it. The Stellarator Wendelstein 7X during construction, December 2011. The last section of the outer shell was just installed. This completes the base machine. I found that at www.ipp.mpg.de. So I googled the word Stellarator to see what it meant. And a stellarator is a device used to confine a hot plasma with magnetic fields in order to sustain a controlled nuclear fusion reaction. It is one of the earliest controlled fusion devices, first invented by Lyman Spitzer in 1950 and built the next year at what later became the Princeton Plasma Physics Laboratory. The name refers to the possibility of harnessing the power source of the sun, a stellar object. Stellarators were popular in the 1950s and 60s, but the much better results from tokamak designs led to them falling from favor in the 1970s. More recently, in the 1990s, problems with the tokamak concept have led to renewed interest in the Stellarator design, and a number of new devices have been built. Some important modern Stellarator experiments are Wendelstein 7X, which is what was featured here in Germany, and the large helical device in Japan. I haven't looked at that one yet. And then the Princeton Plasma Physics Laboratory, I haven't seen that. They started building a new Stellarator NCSX, but as of 2008, work was abandoned due to high costs. Oh, I didn't know that. February 21st, 2012, my thoughts. Again, we get to see current and future projects coming up in the Wow Seti lines of data. Could it be that the formulas and equations are a base for us to look at to create new ideas and equations that can help us achieve our particle colliding goals? Some of the formulas that I came up with would be useful to these new facilities. I'm going to suggest they look at lines 17 and 18 of the Wow Seti lines of data. This is where the formulas start to come up from keywords found in the data. And the formulas usually have either neutrinos in them, argon gas, or different components that go with those two, okay? All other lines do contain researching the meanings of keywords along with inventions, patents, and test results found from all over the world. I will keep you all in mind as I get into the next lines of data. I wouldn't be surprised if I found more formula ideas for you. Okay, so that's the end of that video, and I have to do some more research before I can film some more.